Yes, comparison test. Let summation a n, summation c n, summation d n be a series of non-negative terms. That means or positive terms. Suppose that for some integer n, dn less than or equal to a n less than or equal to c n for all n greater than or equal to n. Summation cn convergence, then summation an also converge. If this summation cn is convergence, then summation an is said to be convergent. If summation dn is divergence, then summation a is also divergence. Here, see one question. Use comparison test to determine the series convergence or divergence. The nth term of the given series, first step we need to take what is the nth term, 5 over 5n minus 1. In the comparison test, we will compare with the given series with the nearest to that series. That means, how can we take that one? You take here in the numerator highest power of n and the denominator highest power of n. Here numerator there is no n term, so you take numerator as 1 and denominator what is the highest power? N, only n, so 1 over n. So you compare this one, this given series with the summation 1 over n. Now as per this p series, this is in the form of p series 1 over n power p, that is 1 over n power 1, where p value is 1. You know that if p value is 1, we have seen in the last slide, if p less than or equal to 1, whether from the p series, it is said to be the divergence. After getting this one as divergence series, now this one you compare with the given series 5 over 5n minus 1. You need to check whether it is less than 1 by n or greater than 1 by n. You take the 5 common and cancel. Here 5, if you take n minus 1 by 5, 5 and 5 cancel, you are getting 1 over n minus 1 by 5. By saying this, we know that it should be greater than 1 over n. Now, if it is greater than 1 over n, then by from the previous slide, you just see here, if it is greater than cn, an less than or equal to cn means what? Cn is greater than or equal to an. If cn is convergence, then an is as convergence. If cn is divergence, an is divergence. By applying this rule here, then we know that already this is summation 1 by n is a divergent. At the same time, the given series is also a divergence. Because when you are comparing the summation 1 by n, summation 1 by n, we know that from the p series it is divergent. So this one also given series also convergent, sorry, divergent. See the another question, 1 over n square plus 30. You compare with what here? Take the highest power in the numerator 1, denominator n square. Comparing with 1 over n square. Now you know that p value, this is also p series, p value 2. P value 2 means greater than 1. Then it is a, if it is greater than 1, then it is a convergent. If convergent, then after you check 1 over n square plus 30 either less than 1 by n square or greater than. See, we know that n greater than or equal to 1, n square less than this one, and 1 over n square is greater than. So if greater than, if it is convergent, as well as this one also going to be the given series also going to be the convergent. Similarly, one more question here is comparison test. We are getting here divergent series. In comparison, also one more is there here, limit comparison. Means you are finding the limit, according to that you are saying that whether it is convergence or divergent. An greater than or equal to 0, n greater than 0, bn greater than 0. Limit n tends to infinite, an by bn is equal to some constant. Then both here, both an and bn series are said to be either convergence or divergence. If you are getting 0, then if bn is convergence, then an also is convergence. If you are getting infinite, bn is divergence, then an also said to be the divergence. You see one example here. Use the limit comparison test to determine the series convergence or divergence. Summation n is equal to 1 to infinite, 2n plus 1 by n square plus 2n plus 1. Take the nth term is this one, 2n plus 1 by n square plus 2. Here also, just compare with highest power is here n and numerator in n, denominator n square. You can take either 2 by n or 1 by n, but here I am taking comparing with 1 over n. Summation bn is equal to summation 1 by n. We know that n value, n power p, p value is 1. So p less than or equal to 1. So it is a divergent series. Now you find the limit value. See, but in the last test, what comparison test? From here only it is divergent, so you are writing direct divergent. But here limit comparison. Limit comparison means you must find the limit here. Limit n tends to infinite. That one also an by bn form you write. Here what is the an? Given nth term, and bn is what you are comparing here, 1 over n. From the limit what you are getting? Some finite value 2. 2 is a finite value. Yeah, if it is finite value, so it is a constant number. From the last slide you see, if you are getting constant, either convergence or divergent. But already we know that here it is what summation 1 by n is a divergent. So summation an is good, also a divergent series by the limit comparison test. See another example also, summation n is equal to 1 to infinite n minus 2 by n cube minus n square plus 3. So find this is the nth term and comparing with what? Highest power n cube. So 1 over n square you will get. N square means it is a convergent. Find the limit again. Limit you are getting 1. This is also one constant you are getting. When you are getting constant means either both convergent or divergent. But in that one already you know that is a Bn is convergent. So An is also going to be the convergent. So exercises, you go through these questions. Thank you.